Welcome everybody to the Meadows Center Blue Bag Lunch and Learn series online. I'm Jenna Walker. I'm Director of Watershed Services here at the Meadows Center. And today I have the privilege of introducing our speaker, Dr. Hwang. And he is an associate professor at the Ingram School of Engineering, as you can see on his slide, here at Texas State University. And we are really excited that he joined the university in 2020 and are hoping to collaborate and share this knowledge that he's brought and is incorporating into the university experience. So he's going to be talking about the green stormwater infrastructure research that he's conducting. And we will allow him about 40 minutes for his presentation, 35 to 40 minutes. And then feel free to enter any questions into the chat, and we'll get to those when we open up for Q&A, or you can save your questions and ask them directly during that time. So please, everybody, if you can mute your mics, you're welcome to keep your cameras on or off, and then we will dive in from there. And Dr. Hwang, I'll let you take it away.
Thank you, Jenna. Well, first of all, I appreciate the Meadows Center for giving me this opportunity. I love it. And also, this is a very special day to me. It's my daughter's birthday. So, so March 19, yes, it's a good day. So yes, as introduced, I'm Dr. Hwang. I'm South Korean, so the name might be a little bit difficult for you to pronounce. So at Texas State, many people call me San, right? So you can call me San, so it's easier. So San Hwang is my name. All right, today's topic is nature-inspired green stormwater infrastructure. Before I jump into main topic, let me introduce about myself. Well, probably from the bottom, right? Yes, I'm a South Korean and master's and bachelor's from my hometown university there. And then I got PhD degree from University of Akron, Ohio. Then I did two postdoctoral works, one at the U.S. Army Engineers, URDOC, and then the other one was at the U.S. EPA. After that, I moved down to University of Puerto Rico, stayed there about 16 years, being as assistant, associate, and a full professor. And I decided to Texas State to join my family. So it sounds like a little bit demoted, right? From full professor to associate, but who cares, right? I don't mind, right? Here we go. So this is my one slide showing my research. And my research interest, as you see here, is related to water, sanitation, and hygiene. And obviously, all of those things are affected by climate change, right? And also, especially, I'm interested in PFAS, like forever chemicals. And I do a lot of waste upcycling as a means of resource recovery. That upcycled material is used for wash purpose, meaning water, sanitation, hygiene purposes. At Texas State, since 2020, as a PI, I was able to secure about 4.6 million so far federal grant. Yes, so these four area is actually my research thrust areas, right? One is, I'm the environmental engineer, so I do a lot of fate and transport and remediation of contaminants like climate impacted, right? So because effects is, everything is uncertain, and then community health and environmental health and safety are vulnerable, and nothing we cannot guarantee these days, right? So again, especially I have interest in PFAS and micro nanoplastics And then, those legacy contaminants, chlorinated solvent and heavy metals. As I mentioned, I do a lot of upcycling of waste or unwanted material. In this case is like I upcycling invasive aquatic plants. You see a lot of water hyacinths in San Marcos River, right? And then I process it and to produce value-added product like adsorbent, hydrogel, or biochar. So I apply them for civil, environmental, and agricultural purposes. And then third one is actually today's topic, isn't it? Pervious concrete pavement and biofiltration as a green stormwater infrastructure. And I actually train students and then have them hands-on experience, on these topics. You see here a lot of students here, right? And lastly, I'm doing a floating island or floating wetland in a field study as a means of in-lake management to improve water, obviously environmental quality, right? So that is something I'm doing. Some of those things I'm doing, right? Well, I got this one from, I believe it's a Facebook, right? Top is showing natural, process, here before rain and then, a lot of rains and then after rain, nature finds its way and then a little bit changes, but there is no, simply speaking, no flooding. Bottom one is what our proud civil engineering is doing, right? So development, and then straighten the channels, and then build the buildings, the houses, and infrastructure, and everything. And then when it rains, flooding, ta-da, right? So that is a big impact to our environment and society, and also human health and safety. So there should be a way to make such impact low, right? So that is a low impact development, isn't it? Alrighty, so this is a world famous hydrograph, right? Hydrograph. So there is a watershed, and then rain comes, and then flowing down, infiltrating down, etc. So if it is a lot of a pervious system, in this case, a pervious meaning soil and grass and engineered pervious area as well, right? Hydrograph will be looking like this, A, right? As a more impervious development going on in this watershed, the hydrograph will be looking like C in this case, so that you will have a lot of flash flooding, a lot of water coming here, okay, coming down to discharge area, right? At a shorter period of time. So that is what we call is a flash flooding, isn't it? So by definition, low impact development and green infrastructure or green stormwater infrastructure shares one common aspect: as close as its source as possible, okay? Or green infrastructure at its source. Bottom line is green stormwater infrastructure is, yes, it rains. However, instead of let it flow down to downstream, let's take care of those stormwater or rainwater when it touches down the ground, meaning at its source, right? So that is a green infrastructure. When we apply more green infrastructure, it will become more low impact development as well, right? Mimicking Mother Nature's functions, right? Infiltrating down. So that's why my title of today's webinar is Nature Inspired Green Stormwater Infrastructure. Nature Inspired Engineering, yes. Alrighty, so this two left and right side compares stormwater runoff management. One on your left is traditional way, which is a conveyance approach. And then right side is green infiltration approach, as you know, right? So traditional conveyance approach is simply speaking, let it flow, let it flow, let it flow, right? To the downstreams. Just let it flow, let it flow, let it flow. So we civil engineers are using culvert and storm drain or channelized stream or stormwater catchment, etc. But if it is a green approach, that is infiltration based. Okay, so basically we retain stormwater or rainwater. We capture stormwater or rainwater. We intercept stormwater or rainwater. We let them infiltrate. Okay, with what? With, as you know, bioretention facilities, rain gardens, and vegetated green roof or rooftop, so green roof, and rain barrels, and pervious or permeable pavement, right? So today I would like to pay attention to pervious and permeable pavement because I only have 40 minutes. I cannot touch everything, right? So maybe sometime later, I'm gonna cover the bioretention basin, things like that. So let it flow, let it flow, let it flow. If you keep doing it, this is gonna happen. Flooding, flash flooding, right? This is actually a previous institution I worked in Puerto Rico, and then the city, and not only there, and in Texas, you guys think about, right? So we have Thanksgiving flooding in San Marcos 2015 as well. So, and then pothole is invisible because of ponding water. So there will be always upstage situation. And then roadside splash is very pleasant moment we, sometimes get, right? So, well, talking about runoff coefficient C, okay? This ratio meaning when one is coming to that specific area, 75 or 85% is flushing off. That is runoff coefficient, right? So this is impervious surface like ordinary concrete pavement or asphalt pavement. Runoff coefficient is about 0.75, 0.85. Compared to that, if it is a pervious concrete system or a permeable concrete system, runoff coefficient C value is very, very low, if not zero. So with all that, we can reduce flooding in the downstream. And I will show you one by one, but anyway, we can have a smaller downstream stormwater management. We can have a smaller retention or bioretention facility so that we can increase land utilization. With all that, this, we can reduce hydraulic force, isn't it? So that assuming you have a soil system here, this water will make a lot of soil erosion. That soil erosion, sediment, or soil particles are going to river, and then you can imagine what is impact there, right? So with all that, we can also have less contaminant transport and drier and safer road. And then more importantly, we can enhance or improve groundwater recharge with this one. So this pervious pavement is a low impact development tool and green infrastructure as well. Oops, sorry about that. So now everybody is fully awake, right? So this is a pervious concrete, and it is actually stormwater runoff control. And it is, let me stop here. It is a water conservation harvesting tool and the smart land development and safer walkable pavement. And also it is reducing urban heat island effect. So I'm gonna explain just one by one from now on. Next slide has also a video, so please careful. Okay, so this is not so bad. So this is just the comparing impervious pavement and then pervious pavement. Seeing is believing. So this is what I would like to talk about, right? So if you have a pervious system, you have less runoff, and then downstream here have less impact. So low impact, isn't it? All right, so the reason why pervious pavement can catch and infiltrate water down is because it has a void content, emptiness, simply speaking, about 20%-ish, right? Emptiness. Because of that, actually, it is a lighter, okay? Long ago, 1890 or 1880, in England, when people, 1910 probably, sorry. When British guys made pervious concrete, they call it lightweight concrete because of emptiness, its density is lighter. So compared to ordinary concrete, right? Because of, again, 20%. So with all that, we can expect the drainage rate about this one. So this video actually showing about 10 millimeter per second infiltration rate. Drainage rate, depending on discipline, it can be a drainage rate or infiltration rate or permeability or something like that. And because of this emptiness, compressive strength is a little bit weaker than ordinary concrete, right? So in my lab and also field application, I was able to make 20 megapascal MPa, 20. About 20 is about 3,000 PSI. So in order to be used as roadway pavement with typical traffic conditions, the compressive strength of pavement should be greater than 3,000 PSI, preferably 4,000 PSI. So typical pervious concrete is not good for the roadway pavement, right? Because of its compressive strength is low. But if you add more advanced material, or you can optimize, you can improve PSI to 4,000 PSI. In local pervious concrete vendor in Austin, they claim 5,000, 6,000 PSI, but obviously with all that, price is going up, right? So it's not sustainable per se. So again, the groundwater recharge is a big thing, pervious concrete, right? So we can, I think next slide will show you. My friend, the San Marcos River Foundation, right, Virginia Parker, frequently upload what is good about Texas in terms of water, right? So this is a recent uploading. And she uploaded, re-uploaded the Texas Water Development Board map here, right? So in Texas, we have 9 major aquifers, as you guys all know, and 22 minor aquifers. So in Texas, more than 55% of our water are coming from the soil system, soil and groundwater system. So it's important to have enough amount and good quality groundwater, right? So to meet this purpose. So going back here, now the runoff water is not clean, right? It may contain some contaminants or anyway, some kind of materials in it. And then this concrete system may not, generate or infiltrate clean water. However, in the lab, our team were able to find the additional functions of pervious concrete by reducing phosphorus reduction, and then obviously fecal coliform reduction, and many other different pervious concrete here, right? And then I think with in this experiment, we also were able to reduce pH to 8.5, because as you know, this is concrete. So concrete is alkali, so pH is high, so no good for groundwater recharge, right? However, there is a way to give our soil and groundwater a good quality water through pervious concrete. So there is will, there is a way. So I found the will here, and then I'm showing you a way. All right, so second topic is we can go even smarter in terms of land development. If it is a typical impervious paver, right? It's shopping mall area, or here is in Texas, actually this is Texas, and this is Houston. So here we have a lot of nonsense detention pond here. So because we have a lot of runoff water is going to downstream, right? So let it flow, and then collect them, right? So this is not smart. However, smarter approach is this one. So we can have less water is running off, right? So we can achieve savings by less land requirement for retention and detention area, right? And with all that, you can more land will be available for other purposes. Maybe you can have more parking stores, or you can purchase less amount of land for development, right? So this is not a rocket science. Everybody can understand. All right. So third one is the pervious pavement system can provide a safer ADA, right? ADA compliant surface and a drier surface as well. This is actually my field project. I renovated a public plaza like this one, right? Like ugly, and then there is some gaps between the pavement and then also the sidewalk, and then wonderful gazebo area, and then wheelchair cannot going up because of what difference in elevation and a lot of cracks and so. So I renovated this public plaza with a previous concrete system. Basically to provide a better environment for the students in this case, and then also to catch stormwater runoff on this specific area. About 3,000 square feet is the total area I worked on. All right, now talking about the fall or safer road. Now, amazingly, I'm active senior now. And then some of you are already senior or elders, right? So look at these numbers. Each year in the US, one of every three elderly person older than 65 years old, in this case, experience a fall, right? So with all that, a lot of health-related issues, and then obviously it's a lot. It costs a lot, right? So pervious concrete system can provide again a safer road, right? Because it does not have ponding on the top of it, and then also its ice accumulation will be reduced. And obviously we can have some conductive pervious concrete as well. And when it's rain or snow, especially snows, and then we can conduct electricity through it, and then it can melt snow on top of it, and then it can infiltrate down, straight down to the groundwater, not let it flow, right? So well, this photo is nothing to do with the fall or something. This is a former graduate student of mine, and then enjoy snow in Colorado, basically. Okay, talking about urban heat island here, because one of benefit of having pervious system is reduction of urban heat island, right? Or urban heat island. As you see here, well, downtown, a lot of impervious area, right? Temperature is about 92-ish or 90-some-ish, but if you have more permeable or pervious and natural area, you have about 85 or something. So about 8 to 10 degree difference is what we're talking about here with permeable system. If it's a natural system, is better. But if we cannot go with a natural system, we can mimic, right? We can mimic natural system. So nature-inspired engineering system can be an alternative way, right? And you guys know Dove Springs in Austin area, right? Dove Spring neighbors. So this is, as you see, September 14, 2023. Last year, we have about 45 or 50 days. Temperature was higher than 100 degree Fahrenheit, right? So Dove Spring people have had about 8 to 15 degree hotter temperature than rest of Austin. This is actual newspaper, right? Austin Vida, right? Austin Life here. So, Dove Spring has been traditionally vulnerable community or neighborhoods, low income, low education, and then poor housing facilities and so on. So city of Austin put a lot of attention and then investment to Dove Springs. So development. So they have now, very well paved area, and then the new buildings, recreation buildings, etc. However, those are good things. However, bad thing is because of that development, right? Just typical traditional development, they experience urban heat island effect now, having their feeling temperature about 10 degree Fahrenheit hotter than the rest of Austin. Right? So think about, we can go smart, we can go low impact development. Think about. So this is what I call is the way we can make smart city, or in European country, they don't call it green infrastructure or green stormwater infrastructure, right? So they call sponge city or smart city. Sponge city is European term, right? So this is actual project drawing that I did, the field project, right? So this is just the roadway, and then this section is pervious system. So with that, bike lane and then pedestrian lane, shared bike and the pedestrian path is constructed with pervious concrete, and then with all that, this section of a city achieved smart city. So with sponge city concept, again, with the green stormwater infrastructure concept here, right? Does not have to be all pervious, right? But some sections can be pervious system, so that we can make low impact development, right? If it is just regular concrete, regular asphalt, it will be just a humongous development, giving a lot of negative impact, right? All right, let me speed up here. So pervious concrete pavement can be made three different design methods. No infiltration, meaning stormwater runoff is infiltrating. However, no water is going down to the soil. That is no infiltration design. So this is a slab, and then this is a reservoir course, and then this is under the drain pipe connected to nearby stormwater catchment, right? So location can be different depending on that stored amount of water in the reservoir course might be different, as you can guess. Another one is a full infiltration, meaning all the infiltrated water is further infiltrated down to the soil. Okay, so because of that, we don't have under the drain perforated pipe, right? And then typically we design a pervious concrete system with a partial infiltration. Some water is going down all the way down to soil, groundwater system, and then some of them are just bypassing to nearby stormwater drain through under drain pipe. Again, under drain pipe location can be different depending on how much you want to hold water in your system, okay, before you release water to downstream. Pervious concrete application, because of structurally they are weak because of 15 to 30%, 35% void content, right? Typically parking stalls are the favorite application here. Okay, so I'm not sure if you went to Pearl Harbor Memorial in Hawaii, and then this big area, parking stalls are pervious concrete. And then this is bicycle parking lot area I created with pervious concrete right in front of General Library here. And another application is like a trail or sidewalk, right? Sidewalk here. And obviously public plaza can be renovated with pervious concrete. And left is mine, and the other side, right side is 2008, I believe. Yes, 2008, when China opened the Summer Olympic in Beijing. They had like 2.7 million square foot of pervious concrete here. You see a lot of different colors here. So this is actually olive branch color too. So depending on location, you can mingle the color of pervious concrete with the surroundings. In this case, we have a very old building looking like olive branch color here. That's why I use olive branch color here. Okay, so anyway, it can be colored. Construction can be done with experienced constructors or installers. With all that, price is a little bit higher than ordinary concrete construction. Typically, we need about 15 people dealing with the roller screed and the raking and etc. So this is a photo, of pervious concrete construction I gave to my students for their public service or and then the service learning project. That's what I want to say. And just wanted to brag about, right? So it's a fun environmental engineering is my motto, my work motto, right? If it is fun, it's not work, although we get dirty, right? So it's all about fun. It's a fun for us and then benefit for environment. So you may ask me, hey, how do we make pervious concrete? Well, typically it is 1:4 ratio, 1 cement, 4 aggregate, okay? Aggregate, and then water content is about 30% to cement amount and things like that. So we can, this is kind of grandfather's, mixed proportions. Hey, 1 cement and 4 coarse aggregate, and then a little bit of water and things like that, right? There is a way, scientific way to make the optimum mixed proportions, right? But I don't think it's a good idea to introduce that to this webinar. Well, as you know, nothing is perfect. There is always a clogging issue. And this is actually San Marcos here, right? So this is a spring lake, and this is a permeable pavement on the side, on the back side of Kirby restaurant right now, right? So if maybe location or maybe design or construction or maintenance are no good, no bueno, then you will have clogging here, right? So as I mentioned, okay, factors for long-lived pervious concrete pavement is obviously design should be perfect, construction should be perfect, and then selection of location is perfect, and then maintenance should be good enough. So this slide show you good example of bad location selection. So this area, actually this pervious concrete I placed, all the water is going to here, all the water is going to here, all the water from here, and then it just accumulate, right? And then it closed, right? Like this one, okay? It just looks ugly, right? So again, this is a good example of bad selection of location. Okay, I did it on purpose to show how important the location selection is. And then maybe the third most, maybe if it is not the most, maybe third most important factor is providing good maintenance, right? Then you may ask how we can provide maintenance. Well, simple blowing is good enough if it is routine maintenance. All right, vacuum sweeping is good. Well, how do we do vacuum sweeping if we don't have this street cleaner and big size one? Well, you can improvise, right? So lawnmower, right? And then lay it down to the ground, and then you can do sweeping as well. So be smart, right? And then for periodic maintenance, you can apply pressure washing as well, right? So in terms of pressure washing, next slide will show you. So pressure washing in combination of vacuum, okay? How high? Well, typical pressure washer you guys have or you guys keep in your garage is 2,500 PSI or 3,000 PSI, right? So just leave it about 2 feet off the ground and then make about 45 to 60-degree angle. Again, about 2 feet off here, then it's good enough. If it's too close, you can make every gravels flying away. Okay, so what you call it, raveling away, right? So don't do that. And well, if it is a small area, yes, you can do that. But what if it is a big area? Big area. Well, you can do. We have actually specialized heavy equipment here, like cleaners. Okay, they actually cleaning previous system as well. Okay. Now, if it is like too close and there is no way just regular vacuum and etc. can work, then you can apply some chemicals as well. There is a commercial chemicals specifically designed for this previous concrete cleaning. However, I don't recommend use of chemicals because they are chemicals. Chemicals are chemicals, right? There is no green chemicals in my world. So do more frequent, routine, and regular maintenance instead of wait until time for the deep cleaning with the chemicals. Okay, so as I mentioned before, it is slightly more expensive than ordinary concrete, assuming 6-inch thick slab. Okay, material cost is about let's say just $10 for square feet, and then after installation, the price is doubled, as you know, labor charge and installation charge. So about yes, $15, $16 is what they are asking for 6-inch slab. However, again, this is a little bit more expensive than ordinary concrete. However, thinking about environmental sustainability benefit, that cannot be counted as dollar unit, right? So we can reduce flooding, and we can reduce, soil erosion. We can enhance ground recharge and etc. and everything. So actually, life cycle cost is much lower than ordinary pavement. Okay? And I found this permeable pavement cost from another resource here. As you see here, there are different permeable pavement, right? So permeable paver, and then pervious concrete, and well, you may ask me, what is a permeable paver? Permeable paver can be those interlocking paver you can see right in front of this Ingram School of Engineering. And then the other side of, the curvy restaurant area, we have permeable paver. Pervious concrete is what we have Sesame Street, that that section we have a pervious concrete on campus here, and then obviously porous asphalt, right? So depending on permeable pavement for square feet, it is around pervious concrete. It is around $8 to $16. That is same as what I said here, right? And then assuming you would like to have 2-car pervious concrete driveway, okay? Driveway. So square foot cost will be, if it is a pervious concrete, it's around $9,000. Wow, it's expensive. Okay, if it is you just put regular ordinary concrete, it's going to be about $5,000 or $4,000. Okay, however, think about the environmental benefit. Okay, you can bring in that is significantly lower life cycle cost, of construction. And have you gone to the new pavement or new sidewalk between RFM building to the way to dormitory area, the way to Harris dining hall or recreation center? We demolished president's house and then we just put humongous, impermeable, ordinary concrete pavement there, right? So I'm not sure that is a very, very green and sustainable way to renovate our campus, but well, I should say what I say here. So anyway, there is a greener, there is a smarter way to go, more low impact development and with more green stormwater infrastructure. So I believe this is my last slide. So this top and bottom drawing compares two different green infrastructure or green stormwater infrastructure. One is typical standalone GI, green infrastructure. Standalone meaning this bioretention is just standing alone, okay, alone. And then other upstream section is impervious pavement, just like our CM Allen Street. We have a big bioretention or bioinfiltration pond there, right? So above upstream, we have bunch of impervious pavement, but at least we provide bioinfiltration or bioretention, green stormwater infrastructure there. However, we can go more nature inspired and we can smarter way, smarter green infrastructure there. How? What if this section, this section is a pervious pavement, right? So with that, we can have less amount of bioretention so that city can utilize that area in other purposes as well, right? Maybe bigger baseball field or something like that. So with all that, I think I'm done, right? Wow, so exactly 40 minutes here. So I'm San. You can contact me, email. I'm just one email away. I frequently upload this green infrastructure and low impact stuff to my Facebook page, hedge.txt. So you can just check frequently if you want. Thank you very much for your time and hope everybody is not that hungry except for me.
Thank
All
you,
right.
Dr. San. That was great. And if you don't mind, I have a couple questions and welcome anyone else to add them to the chat or raise your hand and we can get to those as well. So I love hearing about the permeable pavers, and we have considered installing a couple or some at different parts of the Meadows Center over the years, and we were pretty close to being able to do it in one area that tended to collect a lot of water and after rain events, and ended up running into an issue with the historical society, or I can't remember exactly who it was, but we couldn't dig deeper than 12 inches in that section of Spring Lake. So is there a requirement for the amount of length or depth specifically for those types of pavers you were?
Yes, that is a very good question, Jenna. So typically the pervious concrete slab is constructed 4-inch if it is just a sidewalk, or if it is a parking stall is a 6-inch. Vendor commercial vendors selling 8-inch, or they claim 12-inch. Don't go there. It's just
Okay,
increase
yeah.
the price. So assuming 6-inch, and the below which is water storage layer. So deeper is better. However, if you have 20-inch depth limitation, so 6-inch and then maybe 12-inch, right? So if it is historical regions or historical whatever, and also we are on the Edward Aquifer. So if you are concerned about water quality of infiltrating water, we can design no infiltration, meaning water is still infiltrating. However, it's not going to soil groundwater system. So with that, we can avoid such challenges, and also it can go smarter with AI-based weather prediction, and then solar pump. We installed pervious concrete system, and then depending on weather prediction, we can pump out earlier than storm comes and things like that.
Wow.
That's actually what I'm doing right now, right? So weather climate prediction, and then empty it
Yeah.
before it comes and things like that.
Bring it out.
There is a way.
Okay, well, that's cool. Yeah, I'm remembering it was the Texas Archaeological Society, just because it's an archaeological significant site. But maybe we can revisit that with your support and find some ways to meet in the middle, or make it work. And then I was also wondering, is there any type of off-gassing or waste that is produced over time, or is a product of the substance, or is it mostly just there and then you would have to replace it over a certain amount of time?
A lifespan of pervious concrete system is from 15 years to 30 years. So typical concrete pavement, we go 50 years, but it cannot go that long time because it's structurally weaker, right? So if you provide good maintenance, it can go to about 30 years. If you don't provide good maintenance, or again, location is important, and design, and assuming everything is good, and if you provide good maintenance, it can go up to 30 years and then minimum 15 years. The parking stall I show you in Hawaii, it has been there about more than 30 years now. So I think it's still good. I mean, they are good. So yes, there is no waste or no frequent replacement, because many people actually ask, hey, how often we should cleaning, how often blah, blah, blah. Again, it depending on design, construction, and location and maintenance. Right?
Yeah.
So, yes.
Well, that makes sense. So I've also heard of the permeable pavers that use recycled tires. And have you had any experience with that, good or bad? And I'm also wondering about those types of chemicals breaking down over time.
Yes, I actually made chrome rubber, right? That's what you call it, the waste tire, chrome rubber.
Oh, okay.
Chrome rubber, and then obviously chrome rubber itself cannot be used alone in a concrete system. It has to be mixed with cement. If you don't use a cement, we can use a polymer resin chemicals, and then we can make a pervious system. Again, yes, I made chrome rubber added pervious concrete. Obviously, it feels good when you run on because of cushion, right?
Right.
and then vendors claim that, hey, it's good for your bad knees.
Yeah.
and then, but me, I would like to be honest with you guys. Why? There will be other applications that we can sustainably utilize chrome rubber or waste tire, but in terms of longevity or in terms of structural integrity, adding chrome rubber into concrete system is not a good idea at the moment. Yeah.
Well, that's good to know, and I appreciate.
Well, it's my
Mhm.
opinion, by the way. It's
Yeah,
not.
well, that's great. And I also liked how you were speaking about the gripping effects and how it can prevent falls and slipping, and that's so important, not just for
Yeah.
the older folks, but the younger ones too,
Yes, younger
little
ones too.
kiddos. Okay, well, does anybody else have a question they want to pop in the chat or turn your camera on and ask? All right, Dr. Mia, thanks for joining us. You had to hop off. Okay, well, I'm glad we had this recorded so we can share with partners as well, and really appreciate your time, and look forward to more collaborations, and just thank you for your dedication to this important work as we work to identify opportunities for improving conservation and minimizing, these long-term impacts to our natural environment. So look forward to continuing the good work with you.
Yes, yes. Thank you for the opportunity. Okay, I will see you around. Thank
Okay,
you.
we'll see you